will take some time. Okay. So today we will do one of the most important topic and which we call it as Kirchoffs law of current electricity, isn't it? Now this thing we have also discussed in capacitors, but it was something like trick kind of method which we already established, isn't it? So today we will go through its like depth discussion of it, and it starts with two basic laws. There are two parts in which this Kirchhoff's law is discussed, isn't it? Yeah, so first one is called as Kirchhoff's, yeah, current law, which we also call it as KCL, isn't it? So this is my first law of Kirchhoff's, which is known as KCL. Word or not? Let's see what it is saying. It says that at a steady state, okay, the net current at any steady state, the net current in or at any junction is equal to the net current out from any junction. क्या बोल रहा है कि whatever it says that whatever at it steady state basically means there is no extra presence of charges and all, right or not? So in a steady state the net current of any junction is equal to whatever my current will appear in that junction must be equal to how much current it is going outside. Is that clear or not? Now current outgoing, you can say, definitely you can say that whatever is my current ingoing, that must be equal to current outgoing. Are you able to get me or not? So let's suppose I take two examples of it. Okay. So here let's suppose some kind of current I2 was coming, I1, and this one was I2, and this is I3. So according to current law, that over here at junction, whatever is my net incoming current must be equal to my net outgoing current. Are you able to get me or not? Let's suppose in this is I2, I1, sorry, this is I2, and let's suppose this is also I3. These all are outgoing or not? There is no incoming, isn't it? So I will write I1 plus I2 plus I3 must be equal to how much? 0. Is that clear or not? Now look over here. On the what principle? Basically, this must be based on some kind of principle. Then only I am able to talk about this, isn't it? So how is it possible that net current coming is equal to net outgoing? That means that it is related with charges or not. Basically, we know that charges can't be created nor be destroyed. So how many charges will come, that many charges will go. So basically, this is based on charge conservation. Yeah. Is that clear or not? Is that clear? That it is based on which thing? Charge conservation. So my second case. So this is my first law. Second one is called as Kirchoffs. Yeah, Kirchoffs voltage law, or it is known as KVL, isn't it? So KVL says that basically in some another sense it says that sum of all potential, okay, differences means or drops with the signature or with the sign in any closed loop. Yeah. Yes, in any closed loop of circuit is 0. क्या बोला कि अगर मान लो if there is any kind of a closed loop, so in that if I consider all the potential drops, I'll consider what? All potential drops. Then all those potential differences, if I add all of them together, then the net potential will be how much? 0. It should be equal to how much? 0. Are you able to get me or not? So let's take an example. Let's suppose I have a given circuit like this way. Okay. And there are 4 batteries which are connected. Right or not? I have 4 different, let me put a square. Why I'm building up these things. Okay. So control C, control V, 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 V. Control C. Okay. So I am just putting 4 different squares like this way in this whole circuit. Right or not? In similar kind of orientation is there. It's not like that the orientation is totally different. Okay. And I want to know that, let's suppose these are basically the representation of batteries, and I'll say, let's suppose if the potentials are also mentioned. So this is minus and this is plus terminal, and this is potential V2. This is minus and this is plus and this is potential V3. Are you able to get me or not? This is plus, this is minus, and this is potential V4. And then I have plus and once again minus, and let's suppose this is potential V1. Then what does it says? That the sum of all these potentials in the circuit with the sign must be equal to 0, isn't it? So question arises that you need a sign convention or not. So let us first establish our sign convention. So sign convention is based on 2 ways, right or not? The first one is the selection of your battery, how you are considering your battery. So let's suppose I have a battery. Got it? Oh, sorry. And then I have the sign convention based on my resistor. Right or not? So there are 2 sign conventions. Sign convention of the battery and sign convention of the resistor. Is that clear? So now look over here. Let's suppose if the battery is given like this way, which is E, and here the potential drop will be IR or not. Yes? Now, if you select the method of going from positive to negative, let's suppose if I go from where to where? Positive to negative. Got it or not? Then I am going from a higher terminal towards the negative terminal or not. So this will make my EMF or the potential drop to be negative. क्या बना देगा इसको? Negative. Then if I go from negative to positive, I'm approaching a higher terminal or not. So that means I have which sign? Plus. Are you able to get me? So there are 2 signs. When you go from positive to negative, it is minus E. When it is from negative to positive, it is plus E. Are you able to get me? Second thing is the direction of current IR. If I take in the same direction, if my consideration is along the same direction, then it is basically negative of IR, because I'll go from positive, almost positive to negative or not, because this is positive and this is negative. Is that clear or not? And then if I take the opposite, it is basically plus I. Are you able to get me? Okay. So look over here. In this, the direction In this there is a condition that current direction does not matter because it is dependent on battery's terminal. And here the most important point is plus minus IR is itself defined by my current direction. Are you able to get me or not? Yes. Is that clear? Plus and plus minus IR, like here I have negative and here I have plus or not. Okay. Decided by current direction. Decided by current direction. Is that clear? Right till now, then I'll move that. Okay. Mhm. So now look over here. The question is, then how you have the sign convention now that when I move from positive to negative, I have to consider negative. When I move from negative to positive, I have to consider what? Positive, isn't it? And in the same direction of IR, minus IR, opposite of it, plus IR. Are you able to get me or not? Because we know that this is, if this is current incoming, then this is plus and this is what? Minus. Are you able to get me? So look over here. So when you are writing, let's suppose if you got one closed loop. So I need to apply this sign convention. Then I need to consider my own way of moving inside the loop. So let's suppose if I consider clockwise way. Which way? So when I am clockwise, I will start from V1 or not. Yes. Clockwise orientation means what? First terminal I'm getting positive, then I'll get what? Negative. I'll see that the current is moving from positive to negative or not. Yes. So when the current moves from positive to negative, it is what? Minus E. So what I will write as equation? Minus V1. What I will write? Minus V1. Then you can see here I'm going from what? Negative to positive. Negative to plus V2. Got it or not? Is that clear? Negative to positive once again plus V3 minus V4. Yes, plus to minus. Then that sum must be always equal to 0. So sum of all potential drops inside closed loop is always how much? 0. Are you able to get me or not? So this you have to always remember. If I go from positive to negative, minus. If I go from plus to minus, minus to plus, positive. And second thing is direction of current. Are you able to get me or not? And second consideration is the way I am considering this loop. So first thing is you have to remember the sign convention. Then you are considering a loop, and in that loop, whatever way you are going to move, that sign convention you will get. Is that clear or not? So question arises that basically if I am writing that sum of all potential differences are equal to 0, that means what? There is no force present in the closed loop now. You know that that on what principle it is based. Basically, isn't it is based on energy conservation, that the net work done in the closed loop is how much? 0. Total energy is always what? Conserved. So basically we write that this is based on conservation of energy. And second point is it is based on concept of conservative force, because conservation of energy comes from the concept of conservative. Yes, isn't it? Are you able to get me? Is this clear or not? So this was your KCL and KVL. Okay. Now this KCL and KVL combined, this KCL and KVL is combined with one more important topic. So these two things I teach at the same time, and that is called as series and parallel combination of resistor. So I don't do it differently. Okay, I always combine these two topics. Is that clear? Now look over here. The first connection is series. You are aware of these things in your class 10th only. That when it is a series connection, basically what I will take, I'll consider some resistors putted like this way, isn't it? And so on. So this, let's suppose this is R1, this is R2, and this is R3. Then what will happen? Basically, let's suppose if current I was going. So current I throughout will be same or not? Because number of charge carriers are always same, isn't it? Are you able to get me? So if current is same, then what is different basically? The drops of potential are different. V1, V2, and V3. Are you able to get me or not? So according to Ohm's law, if I apply Ohm's law, then I into R equivalent will be what? Nothing but net sum of all the potentials, isn't it? Sum of all the currents basically. So what I will get? I into V is equal to IR. So I into R1 plus I into R2 plus I into R3 and so on. Because we know that net potential is sum of all those potentials. अरे कुछ तो बोलो हाँ या ना. So therefore I get what? R equivalent is equal to R1 plus R2 plus R3 and so on. Is that clear or not? Are you able to get me? So basically, if I want to find the potential in any one of the circuit is what? If I want to write the potential equation, V1 is what? Simple. V1 क्या हो जाएगा? I by R1, isn't it? Net I, isn't it? Similarly, V2, I by IR1 or what? Yes, basically it is equal to what? V is equal to IR now. So I into R1, similarly V2, I into R2 and so is that clear or not? Consider the second case where we have which kind of connection? Parallel connection. Got it? Now what is going to happen with the parallel connection? So basically in parallel connection we have some loops, isn't it? We get some loops like some resistors are connected in parallel way. Yeah, I get these kind of resistors, isn't it? Okay, so let's suppose I connect them one R, second R, third R, so R1, R2, R3, and they are connected with some kind of a loop, isn't it? So basically, what we used to tell that here, let's suppose if the incoming current was I, then here the current is what? I1, yeah, I2, and here will be how much? I3. But in all of them, one thing used to be very, very common that the net potential drop was still used to be same or not, which was exactly equal to the battery's potential. Are you able to get me or not? Is that perfectly clear? So basically, if this is battery's terminal B, so here I have the drop of, I draw it, many people will draw like this way, that their battery potential drop is B. Right or not? So look over here. If I say that I, so I is equal to what? I1 plus I2 plus I3, isn't it? What is I? I is nothing but V. Yeah, so V by R equivalent. I1 is what? V by R1, isn't it? Similarly, V by R2 plus V by R3 and so on. So this means that in parallel connection, 1 by R equivalent is 1 by R1 plus 1 by R2 and so on. Are you able to get me or not? Is that clear? So look over here. If I have these kind of circuits, I can directly look. You can see that basically I can calculate R equivalent easily or not. आराम से निकाल सकते हैं. एंड अगर मान लो मेरे को करंट I1 पता करना है तो I1 है क्या? I1 इज नथिंग बट V by R, isn't it? But what is V basically? Basically I into R equivalent, isn't it? अगर करंट पता है तो इट इज इक्वल टू व्हाट? R equivalent divided by R1. So I1 is what? I into R equivalent by R1 or V by R1. Similarly, I2 will be written as what? V by R2 or I into R. This is usually known to us. I is usually known to us. R equivalent is usually known to us. So I can find I1, I2, I3 in any circuit by the most easiest way. That I into R equivalent by R2. Like I2 is this much. I3 is similarly same thing. I3 is also, if they are in all parallel combination, so I3 is net current I into R equivalent divided by how much? R3 and so on. Are you able to get me or not? So this is the most important trick which I have told you if the potential drop is same. Okay. Mm-hmm. Got it? Okay. So let us apply some of the things in a very good way to understand what is the meaning of this. Okay. Now see, first thing is series, second thing is parallel, third thing is Kirchoffs law. But still there are some of the most important terms which we are going to utilize before applying the Kirchoffs law. Got it or not? And the first term which is usually going, Arey, where is my, is it what? Yeah. So look over here. So first term, so there are some notes before applying Kirchhoff's law and series parallel connection. The first law which comes into the mind is of the law of conducting wires. So sometimes you will see in the circuit just the wire is given, isn't it? Yes. So what's the meaning of that? Basically, the meaning of that is any ideal wire, okay, which have zero resistance is called as conducting wire. So for any conducting wire, the resistance is how much? Zero. And if the resistance is zero, that means that potential in the wire will be also same or not. So potential of every point, yeah, of conducting wire is similar. Is basically what, guys? Similar. Are you able to get me or not? So let's suppose if I take any wire, got it or not? There are 2 points A and B, and some kind of current I was going through it. Got it? So that means that VA is exactly equal to V of T for any value of I. Got it? Is that clear? Because there is a reason for that. Like, let's suppose if I put, you know that formula like VA minus of VB is equal to IR or not? And in conducting wire, what is my resistance? Zero. And R is equal to 0 for conducting wire. So this is why this implies V of A is exactly equal to V of B. Are you able to get me? The second concept is of use of galvanometer, ammeter and voltmeter. Are you able to get me? So let's suppose if in any circuit, galvanometer, ammeter for any circuit solving, if in the circuit galvanometer, ammeter, voltmeter are given, then what you do? Just replace galvanometer, ammeter, voltmeter, okay, by their resistances. By their, that's all. What you do? Just replace the galvanometer, ammeter, voltmeter with their resistances, and you can solve the circuit. You will get the same answers. Are you able to get me or not? Take third point. Any ideal ammeter. This is the rule for which case? Ideal ammeter. Got it or not? Any ideal ammeter have zero resistance. First important point. Got it or not? Because means I want for any ideal ammeter the net current should be always maximum or not. So that must have a zero resistance. So for circuit solving, replace uh, it or replace any ideal ammeter by conducting wire. That's all. Yeah, yeah. Are you able to get me? Second, third, fourth case for ideal voltmeter. Now, if I want to find any kind of uh, potential, so we use voltmeter, isn't it? And basically, you will see that the voltmeters are connected in what way? Parallel way, such that to find the potential drop or not. And if it is connecting parallelly, that means the net current through the voltmeter should always be zero, isn't it? No current should go through there, such that the voltmeter will have zero potential drop, isn't it? So any voltmeter needs to have, if the current needs to be zero, it should have infinite resistance or not. Okay, so for circuit solving, we replace it by broken wire. Right? Because that net current should be zero. Are you able to get me or not? Is that clear? Yeah, yeah. Sixth point, fifth point. Fifth point is ammeter. Whenever I get a ammeter is always going to read, always read whatever means amount of current passing through it. Second, sixth point, voltmeter always read the amount of voltage drop across it. Is that clear? Is that clear or not? So these are my six important conclusions which we have to always consider. The seventh one are based on means principles, a special kind of representation which we call it as rheostat. In many circuit you will see some kind of this kind of representation, like in between wires there is a resistor, they have a arrow on it. Word or not? Yeah, so rheostat means what? Variable resistance. And then For this case, they will mention you that which resistance they want to consider. Are you able to get me or not? Okay. The fourth, this is eighth point, I think so. And this is of electric bulb. Basically, not only electric bulb, any electrical appliances, whichever you see, it is nothing but it is simply a resistance. Just replace any electrical bulb, any kind of things, resistance. Are you able to get me or not? Is that clear or not? So look over here. Let's suppose if I have any kind of electric bulb, okay, okay, ऐसे मतलब ऐसे दिया जाता है ना electric bulb, isn't it? I think I'll have a special shape of electric bulb. No shape is there for electrical bulb. No shape is there. Set electrical bulb. No. Okay. Why I'll Google it. Let me draw it fast. Got it. These kind of setups are called as what? Electrical bulb setups. Right or not? So let's suppose basically in electrical bulb they tell that it has some power rating P naught and voltage rating how much V naught. Got it or not? So you have to replace. See, this is what? This is their own criteria, own properties. Okay, they do not tell about the resistance of the circuit or they do not tell about any kind of current of the circuit. Are you able to get me or not? So I need to replace electrical bulb by a resistor. So resistance of the bulb will be provided by what? Their rating. Basically this rating, this is called as what? Rating. Okay. Power rating, and this provides the resistance of bulb which is given as R is equal to, most important case, that is V naught square by how much? P naught. Is that clear? And this is what is told that P naught or V naught is my rated power and rated voltage. Is that clear? So these are my some of the important conclusions which we need to always draw whenever we are using the method of KCL, KVL or whatever you wanna discuss. Is that clear or not? Okay, so let us combine all our concepts and do some problems. So these are three different slides which we are always going to use to solve any kind of circuit combination or circuit closure circuits or any kind of a circuit whichever we give it. Okay. Okay. So these five slides are very very important. Okay. So let's take one example. It is saying that let's suppose I have this arrangement. Okay. Battery, resistor, ampere, battery, bulb. So I have battery. Okay. Then resistor. Then once again a battery, and once again a resistor. Right or not? Then once again, and ammeter over here, which we call it as A1. This is 40 volts, and it has 4 ohm of internal resistance. How much is the internal resistance? And this one is 3 ohm. This one is 30 volts and 2 ohm of internal resistance, and this one is 6 ohms. Right or not? A1 is my one of the ammeter, second one is battery, and here I connect with a bulb, okay, which has a power rating of 100 volts and 400 watts. Got it? And this battery is of how much volts? Once again, 10 volts. No internal resistance. Is that clear? And here I have a resistor and a ammeter and a voltmeter. You will be like, sir, क्या दे रहे हो? Resistor, ammeter A2, and a voltmeter, which is of 60 ohm, and this is 2 ohms, and this is ideal. Question is very simple. Find reading of A1 V. Which one? A1 is ideal. Achha, this. It's given 28 ohm. So find the reading of A1, A2 and voltmeter V. Got it? First question. Second thing, power generated by the bulb. Do it fast. Try it, then I'll tell you the answer. What? Yeah, V as no. This V. This V is this voltmeter reading. Opposite. 1 minute. Sorry. This battery is connected opposite. Yes. Just like this. Okay. Do the question. Do it fast. Okay. I'll tell you a step by step how to do this. Okay. The first task is to, if I want to find A1, A2 and V, that means I have to find the current in this loop and find the current in this loop or not. To find the current, I should convert this first resistance of bulb, isn't it? R of bulb क्या आ जाएगा? Voltage is known to us, power is known to us. So right now I gave you the formula. V naught square by P naught. So 100 into 100. So 0, 0, 0, 0 cancel. Basically it is how much? 25 ohms. Is that clear? Next thing is, before finding A2, before finding what? A2, can I just consider, see, A2 is like a second loop or not? This is my first loop and this is my second. And in second loop, there is no external battery. So what I can do? I can just consider this as a single R equivalent or not. Like considering as a single R, which is 20, looking alike 28 ohms. And this is how much? 2 ohms. And this is how much? 60. I have to replace everything as by what? Voltmeter, ammeter, and everything by resistors, isn't it? So net R equivalent of this circuit is what? Simply 30 into 60 divided by 30 into 30 plus 60. अरे कुछ तो बोल आया ना? Yes. So this is what? 90 and 18. So basically R equivalent is how much? 2 ohms, 20 ohms, isn't it? So this is how much? 20 ohms. So what I will do? I'll replace that R equivalent over here to find first the net current in this circuit. So this is how much? 20 ohms. Yes. This is 6 ohms. Are you able to get me? Then 2 ohm as internal resistance is there, so I can draw it like this way or not. 2 ohm. Then I have the battery, 3 volt, 30 volts. Then once again I have what? Battery, which is how much? 40 volts and its own internal resistor, isn't it? So this is how much? 4 ohms. Then external another 3 ohms. Then ideal will be replaced by one more resistor. It is ideal. So basically it will have what? 0. Yeah. A1 ideal I'll write. And this is 10. This is how much? Bulb I have got 25 ohms, isn't it? So I got all my resistors or not? Then what I can do? I can draw my circuit. Let's suppose the current was moving along this direction. I'm considering a loop like this way, clockwise way. In which way? Clockwise. So the current can be seen moving like this way or not? Yes. You start from anywhere. You can start from anywhere and write the equation. So let's suppose if I want to write the KVL equation. Which equation? KVL. So by KVL, what will be the equation? कहाँ से start करें बताओ? 6 से start करते हैं, isn't it? So if the current is flowing like this way and the loop is also same, so minus 6i or not? Look over here. Same direction, negative sign. Kirchoffs law says what? Same direction I have to consider negative sign, isn't it? So look over here. So minus 6i, isn't it? Then once again minus 2i. Then I'm going from negative to positive or not when I consider this loop. So negative to positive means what? It is a positive terminal or not? So plus 30. अरे कुछ तो बोलो हाँ या ना? Then once again minus 4i. Yes, because this is 4 ohms, isn't it? Then once again I'm going from which terminal to which terminal? Negative to positive. So once again plus. Then once again minus 3i. Yeah, because loop direction is also same, current direction is also same. I'm considering that current is roaming like this way. Okay. Then ideal, no current drop. Then I'm getting here plus to minus, isn't it? Minus 10, isn't it? Then last term, once again minus of, because it is once again minus plus, so minus of 25 I, and then once again minus of 20 I. Same direction now. So this must be also always equal to how much? 0. Are you able to get me? So solve this. How much you are getting? 6 to 8 plus 4, 12 minus 3 means 15. 15, 25, 40, isn't it? Yes. So minus 50 means total 55 I, minus 55 I, isn't it? How? Count it once again. Minus 6i minus 2i, 8 minus 4i plus 40 minus 3i minus 10 half. So 12 plus 3, 15 हुआ या नहीं हुआ? 15 plus 25. अच्छा 40 और 40 और 20 तो 60 हो गया ना. So minus 60i, and then how much is this? 40 plus 30, 70 minus 10. So plus 60 is equal to how much? 0. So I की value कितनी आई? 1 ampere. I got I as how much? 1 ampere. And basically this is the current I which is roaming over here or not. So I got my A1 reading or not. A1 reading is how much? 1 ampere. Are you able to get me or not? Now that ampere, that 1 ampere is divided into two parts over here or not? So look over here. Let's suppose this is, I consider like this way. So this is my here 1 ampere of current, isn't it? And here let's suppose the current going is I1 and here the current going is how much? I2. Are you able to get me? So I can write equation of I1. I told you right now. I1 is what? I1 is, if look over here in parallel connection, how to find it? I1 is I of R equivalent, I into R equivalent by R1. R equivalent, you know, in this parallel it is how much? 20, isn't it? Right now we have calculated. And I equivalent is 1. So what is that? I equivalent 1 into R equivalent is how much? 20 divided by the R's to resistors, isn't it? Yes, basically, isn't it? Basically, what it is? Arcs to resistor R1, R2, R3, and all. So here in both the 28 and 2, the current will be same or not, which is equal to how much? 30. So basically, I1 will be how much? 2 by 3 amperes. Is that clear? Which is the reading of second ampere. Is that clear? Similarly, I2 will be what? Current is 60. R equivalent is once again 20 divided by 60. Yes? Basically, I am getting how much? 1 by 2. That's my amps, isn't it? So net, if I know my I2, then I know my voltage drop here or not. So reading of V is how much? I know my current, which is how much? 1 by 2. And how much? 1 by 3 आया क्या? अच्छा 2 3 जा 6 ना? Okay, okay, okay. So 1 by 3 basically. So this will be how much? 1 by 3 into the net resistance, which is how much? 60. तो कितना है? 20 volt. So reading of this voltmeter is how much? 20 volts. Are you able to get me or not? Yes. Second question is power generated by bulb. So look over here. See, power given. This is my rating. This is 400 watt is what? Power which is the bulb can intake But actual power is that or what? No, it can be different also or not. So power generated is simply what? What is the formula of power? Current supplied I square R, isn't it? So whenever you get this bulb kind of question, the first task is the power given will provide you the resistance, but the power generation is provided by my current. Are you able to get me? It is given as I square into how much? Resistance. There are two kinds of. Are Baba, एक बात बताओ. If there is a bulb, okay, so basically it will have some own voltage drop that. अरे तुमने देखा नहीं है क्या बल्ब में ज्यादा लाइट डालने से बल्ब फ्यूज होता है या नहीं होता? तो इसका मतलब क्या है कि बल्ब जो है वो कुछ पावर को सह सकता है, कुछ वोल्ट को सह सकता है ना. तो बेसिकली ये इसको क्या बोलते हैं, इसी चीज को बोलते हैं रेटिंग्स. इसको क्या बोलते हैं? Rating. And that provides the resistance of the bulb. Are you able to get me or not? That does not help into finding the current provided through the bulb. Is that clear? So there are two things: power rated, and the power supplied. So power rated depends on this voltage given and the resistance of the bulb. Are you able to get me? And power supplied depends on how much current I have supplied and the resistance of the bulb. Is that clear or not? So if it is asked that find the power consumed, then it is not equal to 400. Okay, it is equal to how much basically? I square R. I की value कितनी है बेटा? तो I through the bulb is I1 and I1 is 1 ampere and resistance of bulb is 25. So it is taking how much watts? Only 25 watts. So see, it can take how much? 400, but power generating is how much? 25, which is less than 400 or not. So definitely this bulb will never ever fuse. Is that clear? Got it? Can we move ahead? Okay. So this is how you are going to solve ammeter, voltmeter, any kind of problem. Okay, so this is why I kept one big question so that you can understand. Okay. Now this was the series and parallel connection. Let us understand one more type of a problem. All right. Let's suppose the circuit is given like this way. Okay. Alright, there are two resistors. One is 5 ohm, another one is 2 ohms. And this is my battery of 20 volts. And this is my battery, what's opposite, sorry, of voltage 10 volts. Okay, question is this is A, this is B, this is C, and this is D. So question is find current I in wire AB, BC, BD and BC. बताओ. Srishti, tomorrow morning 7 a.m. it's not the class. Evening only we'll keep it, okay? 9:30. Ah, 9:30 I'll take only because I might not get free in the morning. I do not know whether my class is there or not. Okay, another class. Okay, do it fast. 9:30 confirm. Do it. 1 minute. Try to do it. Can you do it? Should I help? Acha, first thing is, yeah, current will distribute. So there are two ways to do it. Wait. The first one is never include three currents over here, void or not. So let's suppose if I am considering over here as I1 and here some another current is coming as I2. So here how much current should come? I1 minus I2, isn't it? Got it or not? Why? Because I consider I1 minus I2. Because there is no resistor. So no need to include this equation of I1 minus I2. That's why I'm not considering this. Are you able to get me? Huh? Got it? Yeah. Because if I include I1 minus I2 over here, then there are once again two variables or not. Okay, so now look over here. If this is I1, so this is also how much I1 and here also it will flow like I2. Then I need to consider the loop rule, isn't it? So if I consider the loop rule, I have to consider the same way of rotation, isn't it? So when I am going from here, the current goes from positive or negative. So look over here. Let's suppose this is first loop. Let me mark first, second. So I'm writing the equation for first loop. Are you able to get me? Yeah. So it's going from which side to which side? Negative to positive. Plus 20. Then it is in this loop direction is same of the current direction or not? Minus 5 I1, isn't it? And that should be equal to how much? Since there is nothing else in this, So that must be equal to how much? 0, because here I1 minus I2 is not connected with any resistor. Are you able to get me? So this implies I1 is equal to how much? 4 amperes. Similarly, if I take the second loop, here also the current is passing from negative to positive, isn't it? So plus 10, then once again it is going in the same direction. Loop direction and current direction is same. So 5 into I2, which is equal to 0. So this implies I2 is equal to how much? 2 amperes. Yes. And then what I will consider? This is 2. Then what I will consider over here? Then next I can know I1 minus I2 or not. I1 minus I2 is how much? 4 minus 2. So basically this is also how much? 2 amperes. Is this clear? Now this is what? First method, isn't it? But that day I told you there are another method of handling this, isn't it? Yes. And we call it as the junction rule. What we call it as? Yes. So let's what we used to do. We used to consider that the downward grounded junction is always at zero potential or not. So let's suppose here it is what? 0 volts. Now you know that for conducting wire the potential around all the points is same. Here there is no resistance, so this is also at what potential? 0 volts, isn't it? So let's suppose there would have been three currents moving like this way. I1, I2, I3 like this way. Got it or not? So I1 here there is no such condition of another current. So what I can write? I can write directly equation or not? I1 is equal to sir J. What is that? 0. First, what I am getting? If I'm considering I1 like this way, okay. So what I will get? I'll get 0 minus of first potential is 0, then minus of first I'm getting positive terminal or not? What I'm getting? Positive. So I need to consider it to be positive. Plus 20 divided by how much ohms is there? 5. So this means how much is this? Minus 20 by 5, which is how much? 4 ampere or not? Which is most easiest way, isn't it? But I'm getting minus. Minus means what? If I consider I2 like this way, I1 like this way, then I'll get minus 4 ampere, which means that I should always consider the opposite direction. Are you able to get me? Is that clear? Similarly, I can find I2. I2 is what? First is 0, then minus. Once again, I'll get what? Which potential? Minus over here is there or not? So minus of minus 10 divided by how much? 2, which is equal to how much? Basically, 2 5. Uh-huh. I have taken wrong equation over here or what? Here this is to be 2I2, no? Resistor is 2 now. So this should be 5 ampere, isn't it? Is that clear? This is basically I1 minus I2. That means the direction is actually opposite, isn't it? So I1 minus I2 is basically opposite direction. Got it? Which is equal to 1 amperes. Okay. So basically this is what I showed, that I2 is equal to how much? 5 amperes, and that is correct, isn't it? And you can find I1 minus I2 easily or not. Is that clear? Got it? So these are two different ways. Two different ways. So basically this is called as point potential method. क्या बोलते हैं इसे अपन? Yeah. Or it is also known by a name of nodal analysis. क्या बोलते हैं इसे अपन? Nodal analysis. Are you able to get me? Is that clear? Okay. Can we move to next question? Do you want to solve one more question? Okay. So look over here. I'll give you a tough one, a tough nut to crack. Okay. बोल रहा है कि okay, this is plus 10 volts, minus 50 volts, 20 volts, minus 30 volts, right or not? Then resistance and a battery. Battery and a resistor. Battery and a resistor and just a resistor. Is that clear? So resistance and a battery. Okay. Battery and a resistor. A resistor only and the battery. So this is given 2 ohms, 5 volt, 15 volt, 2 ohms. This is 20 volt. Okay. And this is 1 ohm. And this is 1 ohm. Got it? Yes. Question is simple. Very, very simple. At origin, if this is point A, then question is find the potential at point A. And yeah, and current through each circuit. Do it fast. Can you do it? It's easy peasy. It can be solved very easy. Okay? Can you do it? Should I do? Acha, which principle I'll apply? This is just looking like a junction principle or not? Consider this as X potential, isn't it? I can consider this A as what? Potential at A, and consider the currents like I1, I2, I3 and I4. You know that any junction, these are all outgoing currents or not. So I1 plus I2 plus I3 plus I4 is equal to how much? 0. Isn't it? Yes. So if I write I1 plus I2 plus I3 plus I4 is equal to how much? 0. So basically I1 is what? This is X potential, isn't it? This is at what? X. So equation will be what? X first I1 will be developed by the all potential differences. So X minus. Then here it is positive or not? So 5. अरे कुछ तो बोला है ना? So that means what? Note is simple. If I find first positive terminal in the direction of current, the battery potential is positive. Is that clear? But in KCL, KVL, I have to consider opposite, isn't it? If same direction, then it is negative. Opposite direction, then it is positive. In junction rule, it is just opposite of what we have studied in KCL and KVL. Okay. Then once again, minus of the second potential, which is minus 50, divided by how much? Through how much resistance it is passing? 2. So this will be my 2 ohm resistance. Are you able to get me or not? It's not. I am doing the nodal analysis. Listen once again. This rule is not a junction rule. Look over there. Did I say that it is a junction rule? What I have told. It is point potential method. So point potential method is opposite of what we have studied. That's what we have to remember as a trick. Got it or not? So when I am writing I1, I1 will be written as net change in potential divided by resistance. Is that clear? यही होना चाहिए ना I1 कैसे जनरेट होगा ड्यू टू नेट पोटेंशियल डिफरेंस सो नेट पोटेंशियल डिफरेंस इज हाउ मच x minus the first one is plus so plus 5 then another change in potential is due to minus 50 so minus of by how much resistors this net potential is across 2 so I1 is V by R change in potential divided by R is that right I2 will be first x then once again minus same I'm getting minus 15 then it is plus so minus of 20 divided by net resistance 2 plus this is how much x minus of I'm directly getting 20 minus 20 then I'm getting minus 10 isn't it divided by net resistance of how much 1 are you able to get me and last one is of this isn't it so plus I4 x minus of minus 30 divided by 1 is equal to how much 0 so first equation this is plus 50 minus 5 to plus 45 x plus 45 by 2 plus this is x minus 5 to 1 3 35 by 2 isn't it plus this is x minus 30 by 1 plus x plus 30 by 1 is equal to how much 0 इसमें 1 ही है ना ठीक है so can I solve this equation or not what I will get let us so basically I can take LCM isn't it so this is x plus 45 plus x minus 35 plus 2x minus 60 plus 2x plus 60 is equal to how much 0 60 60 got cancelled what I'm left with so I'm left with then this is x 4x plus 5x plus 6x isn't it 1 2 3 4 5 6 6x this is what 45 minus 35 just plus 10 is equal to how much 0 so x is equal to minus 5 by 3 volts this is your answer is that clear now if you know your x I can find I1 I2 I3 and all not I1 is what x minus 5 by 3 and then it is what plus 45 divided by 2 are you able to get me this is my value of I1. Are you able to get me? So how much is this? I1 is equal to, if I do all the sum, 445, you just do it, minus 5 plus 45 into 3. 3 5s are 15, 4 3s are 12, 113. So 135 divided by 3 into I1 is equal to minus 130 by 3 to the 6. You solve it, you will get the answers. Is that clear? Acha, plus, yes. Similarly, you can calculate I2, similarly, you can calculate I3, I4, I5 and all, or not. So this is the use of, see, first thing I taught you KCL, KVL, and second thing I taught you how to use the trick rule, which we also call it by a name of point potential method. Are you able to get me? Are able to get me? In point potential method, the rule is consider all the current outgoing from the junction. Then the sum of all those currents is exactly equal to how much? Zero. Okay. Okay. So today we will stop till over here only. Okay.